Hello everyone, this is Mr. Burris again, and I want to continue going over how to do some parts of the Excel project, which is the major final project for MAT120. If you are taking the course following the summer session of 2017, the Excel project has been expanded. And so instead of being just 10 parts, now there are a total of 17 parts to the project. In a previous video, I showed how to complete the first 10 parts of the Excel project and how to upload your completed project to me for review through the D2L assignment box. I now want to go over how to do the remaining 7 parts of the Excel project that I did not go over in a previous video. So we'll start with part 11, which is the box plot. And the instructions are to go to page 173 in the textbook and do problem number 12. So if you don't have a hard copy of the textbook, you can always open up the electronic version of the textbook through Connect Math. Now the instructions for completing the box plot are to go inside Excel, click on Insert Recommended Charts, then All Charts, and find the box and whisker plot. That is if you are using the 2016 or newer version of Excel. On my home computer, I am using the 2010 version, so I don't have all the most recent bells and whistles, but I will show you how to create a very easy Excel box and whisker plot through this 2010 version. And if you wish, you can follow the instructions through the book on how to complete the box and whisker plot through Excel using the newer version. So as an example, I have loaded a data set. It's got 11 values in it. And of course, in order to do a box and whisker plot, we need the 5-number summary in Excel. So that, of course, entails the minimum value. So I'll call that min. We need Q1, the first quartile. We need the median. We need Q sub 3, and we need the maximum value. And now we want to go into Excel and have the Excel functions extract the information that we need for our box plot. So the first thing we'll want to do is go into Formulas, under More Functions, the Statistical Functions, and we want Excel to find the minimum value in our data set for us. So we'll click down here at minimum. Then a field is highlighted. You need to highlight where the data is located. In my example, it is field column A, fields number 1 through 11. And then click OK. It goes through the data set and returns the minimum value. Then we'll want Excel to calculate the quartiles. So this will be statistical. Come down here to the quartiles. We want to select quartile inclusive. Again, highlight the data and tell Excel that we want quartile number 1. Then go to statistical functions, select the median. Tell Excel where the data is located and it will return the median value for our data set. Then we want quartile number 3. So back up to More Functions, the Statistical Functions, down here to the Quartiles Inclusive function. Select where the data is located and tell Excel that you want quartile number 3. And finally, we want Excel to identify what our maximum value is for our data set. So we will select the maximum function, tell Excel where the data is located, and it will return the maximum value. So there's our 5-number summary. And in the newer versions of Excel, you can use these 5 data values and construct a box plot directly. If you have an older version of Excel that doesn't feature a box and whisker plot directly, you'll have to create one. And there's a little bit of manipulation that needs to be done. So we need to enter some additional data fields in order to construct this box plot. So I'm going to include 3 extra data values. I'll call them Series 1, Series 2, Series 3, This should be series 3, series 4, and finally series 5. Now series number 1 is going to be the minimum value. So we want to start with the minimum value. And we just want to enter the field where that minimum value is located. On my example, it is in field E1. Now series number 2, I want the difference between the first quartile and the minimum value. So we need to tell Excel to do a calculation. So we're going to hit the equal sign to tell Excel that this is a calculation. And I want the difference between the first quartile and the minimum value. Well, the first quartile is located in field E2, and I want to subtract the value of E1. And that's a difference of 19. Then for series 3, I want the difference between the median and Q sub 1. So again, I'm going to do a calculation, enter the equal sign, and subtract E3 minus E2. For series 4, I want the difference between the third quartile and the median. So again, an equal sign, E sub 4 minus E sub 3. You notice a pattern? Oops, see, that's not correct. E sub 4 minus E sub 3. There you go. And for series 5, I want the difference between the maximum value and Q sub 3. So the maximum value is located in field E5. I want to subtract the value that's located in field E4. It is these series values that I am going to use now to construct my box and whisker plot in Excel. First, I'm going to start off by highlighting the very first 4 series and their associated data values. So highlight the first 4 series that we have just created, and then go into Insert, and I want to insert a column chart, and I want a 2D stacked column chart. Now this doesn't look like what I want, so I'm going to come over here up in the menu ribbon and select Switch Row and Column. And that gives me a stacked bar chart. The next thing I want to do is to completely eliminate this lower box, the series of 60. And to do that, click the box, Format Data Point, up to Fill, select No Fill, and for border color, select No Line. And it is sort of ghosted out. If you move your cursor outside of the box where the box plot is being constructed, that field will completely disappear. We'll be dealing with that in just a few minutes. Next thing I want to do is go up to series number 2. It is on my screen a red box, and do the same thing. Format the data series, go to Fill, I want No Fill, and a border color, I want No Line. And it is ghosted out as well. But this time, we're going to include our whiskers. And to do that, I want to select the Layout option and Error Bars. Then select More Error Bars options. Now I want to do a minus because I'm going to be providing an error bar between the minimum value and our value of Q sub 1. So I want a minus, and I want my percentage to be 100. And select Close. And there's our line connecting our minimum value of 60 to our value of Q sub 1. Now I want to do the same thing for the maximum value and Q sub 3. So I'm going to come back up here to Error Bars. This time I want a plus, and instead of selecting the percentage, I'm going to include my custom value, and I specify the value located in Series 5, and that is 4.5, because I want to go 4.5 more than the value of Q sub 3. So I'm going to select value, and then just tell Excel that I want the whisker to go 4.5 units more than Q sub 3, and click OK. And there is my box and whisker plot. All of the quartiles are there. The quartiles are there. The median is the line separating the green region from the purple region. The box and whisker at the very end connects Q sub 3 to the maximum value. And at the bottom, I've got a whisker connecting the minimum value of 60 to the value of the first quartile, which is 79. Now I need to give my chart a title. So I'll select chart title, and I'll just call this box plot. Boop. Don't know what's going on there. And there's my box and whisker plot. I don't need these series anymore over on the right hand column, so I'll just click and delete them. And there's my box plot. And I'm going to change the title of this particular sheet to box plot to describe exactly what is being shown. So I just highlight, and that's not working, I'll just highlight the whole title and then select whatever title I want to give it. And then, like I have done in all the previous parts of the Excel project, after I have finished them, I'll always want to hit the Save button. You never know when you might experience a power outage, and if you haven't saved your work, you might, whatever you've worked on since the last time you saved might not be saved. So always click that Save button whenever you have completed a part of the Excel project. And there's our box and whisker plot. Now, if you've got as I said, if you've got the newer version of Excel, it's much easier to do this. There's an actual box and whisker plot function that you can use. And I'll be showing the students how to use that in class. Our next part of the Excel project is to calculate a z-score for the following data set. So you'll want to enter these data values into an Excel sheet and then find the z-scores for 659 and 489. The instructions for this are given on page 163 and 164. But let me just show you how to do this very quickly. So I've got a data set here, and it's listed, it consists of 8 values, and I want to calculate a z-score for the value 480, and then I want to calculate one for the data value 314. Now remember, for individual data values within a data set, the z-score is the difference between the data value of interest and the mean for the data set divided by the standard deviation of the data set. So in order to do this, I need to know what the mean and the standard deviation are. I've got several options for doing this, but the easiest way to do it is to load your data analysis tool pack and have it calculate your mean and standard deviation for you. So highlight the data, let's see, go to data analysis. I want descriptive statistics. Tell Excel where the data are, and this is the data are in columns A 1 through 8. Tell Excel where you want the descriptive statistics to start. So I'll just tell it that I want the chart to start at field A10, and make sure that summary statistics are included, and click OK. And I'm getting an error. Input range must contain at least one data point. And it does. Well, let me try this again. Let me clear that whole thing out and try this again. And there are descriptive statistics. So we've got the mean, the standard error, median, mode, and down below is the standard deviation. And now I'm ready to calculate the z-score for 480 and 314. For 480, because I'm doing a calculation, I'm going to hit my equal sign. Then I need to calculate my numerator. The value of 480 minus the mean, and I'll say 426. I'll just take the data value that is in field B12, so I can minimize my typing. And actually, 480, we could just let Excel call up that data value for us, and that's in field B5. And now I need to divide that difference by the standard deviation, and the standard deviation is in field B16. And there is our... That's not correct. That is not correct. B5 minus B12 divided by B16. It is not 1.56 standard deviations below the mean. Oh, silly rabbit. My data value isn't in B5, it's in A5. Okay, that's more like it. So data value of 480 is 0.20 standard deviations above the mean. And for my data value of 314, I'm going to have it calculate the difference between, let's see, 314 is in field A3, minus my mean for the data set, which is in field B12, and divide this by my standard deviation, which is in field B16. And 314 is negative 0.4148 standard deviations below the mean on the Z distribution. So there are my Z scores. That completes part 12 of the project, and of course I'll want to click Save. Next, under the Excel project description, is a counting problem. I want to find the permutation for problem 13F on page 235, a combination for problem 34C on page 236, and calculate a factorial for problem 14B on page 235. And how to do this, the instructions are given on pages 239 and 240 in the textbook. So in my Excel project, I've got something similar here. I want to calculate a permutation of 9 things taken 2 at a time. Then I want to calculate a combination of 9 things taken 7 at a time. And third, I want to calculate 8 factorial. And I'd like Excel to do this for me. For the permutation, I need to insert a formula. So I go to Formulas. I can either use the statistical function, or I can come down here to the math function. The math function doesn't have a permutation, so I need the statistical function, the permutation. You enter the number of items that you have, which in this case is 9, and the number that you're selecting at a time, and that would be 2. And so permutation of 9 things taken 2 at a time is 72. Then for combinations, that's located under the math functions. So select combine, the combination, the number that you have, number of items overall, and how many you're selecting at a time, which in this case is 7. And we find that that's 36. And finally, I want to calculate 8 factorial. So back up to the math and trig functions. FACT is the factorial, and I want it to calculate 8 factorial. 8 times 7 times 6 times 5 times 4 times 3, and so on. And that's 40,320. And that takes care of that part of the Excel project, and I'll just label that as counting, and of course hit Save. Next up on the Excel project is to find the area under the normal curve for problems 14, 18, and 24. So in my sample Excel project, I've got something very similar. I want to find the z-score, or the area to the left of z equals negative 1.87 under the standard normal curve. I want to find the area to the right of z equals 0.38 under the standard normal curve. And then I want to find the area between z-scores of negative 0.27 and z equals 0.88 under the standard normal curve. For the area to the left of negative 1.87, I'm just going to come up here and include a statistical function, and I want the normal distribution. That's not the one I want. I want the normal S distribution. So you calculate your z-score, which is negative 1.87. And since we're talking about cumulative areas, for cumulative, just put true. And the area to the left of negative 1.87 under the standard normal curve is 0.0307. As we remember from class, to find the area to the right of a certain z-score, we have to find an area to its left under the standard normal curve and then subtract that area from 1. So for right of 0.38, I want to come back up here to statistical functions and do the same thing I did in the previous example. Select the normal S dot distribution. Tell it that I want a z-score of 0.38, and for the cumulative, enter a logical operator, which is true. But I need to subtract this value from 1. So after the equal sign, I'll just enter a 1 minus, and it subtracts the cumulative area to the left from 1 and leaves us the area to the right of z equals 0.38 under the standard normal curve. And for the areas between z equals negative 0.27 and z equals 0.88 under the standard normal curve, I just need to calculate 2 cumulative areas and subtract their areas. So I will first do the normal S distribution for z equals 0.88, my larger value, and return a true for the cumulative column, and then subtract out the area to the left of z equals negative 0.27. And the area between those two z-scores under the standard normal curve is 0.41699. So I'll just call that areas for my tab title and click Save. Part 15 of the project is to find a z confidence interval for problem 16 on page 380. The instructions for doing this in Excel are listed on page 381 in the textbook. So I've got a data set here with 31 data values, and I want to calculate a z confidence interval, and we'll make this a 95% confidence interval. First thing I need to do is to calculate my mean, and I need the standard deviation for this. So I'm going to go back up to data analysis and do descriptive statistics once again. Tell Excel where the data are located. And I think I'll put this data, I'll list it in field C1. And make sure summary statistics is highlighted. And there are our summary statistics. You can expand the column to see what the descriptors are. And now we're ready to calculate our confidence interval. The first thing we need to do is to find our margin of error. And to do that, we're going to come up here to Formulas, Statistical, and I want a confidence.norm because I want this to be a z interval. The alpha level is the decimal equivalent of the confidence level that you are working with, and since I want a 95% confidence level, this is going to be a If it's 95%, that means my alpha level is 0.05 or 5%. 5% expressed as a decimal is 0.05. So I want my alpha level to be 0.05. My standard deviation is given in my summary statistics, 22.8. And I have a sample size of 31. And that returns the margin of error. That is not the confidence interval. I need the lower bound for the interval, and I need the upper bound for the interval. So I need to come down a couple of rows, put a label in for lower bound and upper bound. My lower bound is going to be the mean minus the margin of error. So my mean is located in field D3, and I want to subtract the field in F1, which is our margin of error. So our lower bound for this interval is 51.19, and our upper bound, I'm going to take the mean, so equals, take my mean, which is located in field D3, and add the margin of error, which is located in field F1. And so with 95% confidence, we can say that the true mean for this population, whatever this data set happened to come from, is somewhere between 51 and a little more than 67. And since that's a z interval, we'll change our tab label to z interval and hit save. The next part of the Excel project is to do the same thing, just using a t confidence interval for a smaller data set where we don't know the population standard deviation and have to rely on the standard deviation of the sample. So for problem 18 on page 388, the instructions for doing this are on 389, but I'll show you how to do this. Here I have a smaller data set. It's only got 12 data values. Again, I need the summary statistics. So calculate data, my data analysis. I want descriptive statistics. Highlight the fields where my data are located. I'll just put the chart in C1, the summary statistics, and click OK. Now, like I did before, I need to find the margin of error for this data set. So I'm going to come up here to Formulas, More Functions. I want a confidence level for a confidence interval for the t-distribution this time around. Again, I'll use 95% confidence interval. That means alpha again is 0.05. My standard deviation is 13.5. And I have a sample size of 12. So I get a margin of error very similar to what I had the last time. So I need lower bound for my interval and an upper bound. Take the mean for the sample. So I want the data value in field D3, and I want to subtract the field in F1, my margin of error. And then for the upper bound, it's the mean from field D3, and I want to add my margin of error, which is located in field F1. And then click Save. And that is my t-interval. The last part of the Excel project is to make a scatter plot and find R for problem number 22 on page 562. This deals with correlation and the scatter plot, which we'll be discussing next week in Math 120. And so, because you're asked to do the life expectancy problem, I'm going to do one very similar, which is water and carbohydrates. And I've got listed the number of grams of water and the number of grams of carbohydrates for a random selection of raw foods. Is there a linear relationship between the variables? So I have copied this data set here. So I've got the amount of water and the amount of carbs. And I want, first of all, to create a scatter plot between these two variables and see, is there any kind of linear relationship that exists. So I want to insert a chart. I guess let's highlight the data first of all. Once we've got the data highlighted, just select scatter plot, and there is a scatter plot of the data between carbs and water. Now I need to include some axis titles, so I want a primary horizontal axis title below the axis, and this will be water content. I can make my chart a little bit bigger. And then I need a horizontal, vertical axis title, and I'll call this carbs. And my title needs to be a little bit more descriptive. Scatter plot between water and carbs. And so you can judge for yourself whether you think there's a positive linear relationship, no linear relationship, or a negative linear relationship. Certainly looks like a very strong linear negative relationship. It looks like as the amount of water increases, the carbs decrease, and it seems to make sense given what we know about nutrition. So that's our scatter plot, and then to calculate our correlation coefficient, that is the value R. So we will come up here, select a field somewhere on the chart. We want a formula. I guess first of all we need to highlight the data. Select Correl for correlation. So the array, that's going to be the first data values. Oop. Let me get out of that. Correlation. So the array will be the data values for water. Array number 2 will be the data value for carbs. And indeed, we have a very strong negative linear relationship, almost perfectly negatively linear at negative 0.99268. That's our correlation part of the project. Click Save. Now that's the last part of the Excel project. And like I showed before at the end of the prior video, once you've got your project saved, if you would like me to go and take a look at it, you can go to the Assignment tab in Excel. Oh my goodness. You know, these things never happen when I'm practicing for real. But once I do these things for real, I think, okay, well, we're open right here to our Excel project box. And let me log in as a student to show you what you will be, how it will appear to you. So I hope if you're viewing this video that you decided to stay in the class. Yesterday was the last day to withdraw for the spring semester. I haven't checked my roster to see if anybody took advantage of that. Most people are in pretty good shape this semester, so I wasn't expecting very many people to withdraw. But if you want to post your project for me to take a look at, or publish it for the final time before the April 30th deadline, just click Excel Projects. You're given a rubric. This is how you're going to be graded on each of these things. So just make sure that everything in this left column is included on your chart, and you should have a pretty nice grade on this Excel project. And if you want to submit your file, select Add a File, tell D2L where your file is located, and let's see. Let's see. Okay, well, this isn't the correct file, but just add it You can leave me a note if you want to. Please look over my Excel project and click submit. And in just a few minutes you'll receive a notification from D2L to verify that your project was received by me, and next time I log into D2L I'll take a look at it. And that's how you complete the MAT120 Excel project.